Dear students, under the topic multiple integrals, we are solving problems under triple integrals. Now, here we have problem 8, which is a very significant question in the examination point of view. The question is to evaluate triple integral xyz dx dy dz taken through the positive octant of the sphere x square plus y square plus z square is equal to a square. So now the equation of the sphere is given here and we consider only the positive octant of the sphere. So considering the positive octant of the sphere, we have to evaluate the triple integral xyz dx dy dz. For this, first we have to find the limits of these integrals with respect to x, y and z. So in order to do that, first we shall write the given equation of the sphere. So after writing, let us mark it as equation 1. Now we have to find the limits for these integrals. First we shall find the limit for z. That is, so in order to find the limits for z from equation 1, so from this equation 1, having z on one side, we can take the remaining terms, that is x square plus y square, to the right. So we will be getting a square minus x square minus y square. From this, z will be equal to plus or minus square root of a square minus x square minus y square. So now we are given that we are considering the sphere only in the positive octant. So z will vary only from 0 to square root of a square minus x square minus y square. You could imagine the that is this will be minus square root of a square minus x square minus y square, and at some point of the line you will have 0 and you will be having plus a square minus x square minus y square. Now since we are considering only the positive octant, we will not consider the negative values. We will consider only from 0 to square root of a square minus x square minus y square. Hence the limit of z varies from z equal to 0 to z is equal to square root of a square minus x square minus y square. So therefore these are the limits for z. Next let us find the limits for y. Now in order to find the limits for y, in equation 1 we have to put z equal to 0 in equation 1. Since we will be considering the xy plane, so in the xy plane z will be equal to 0. Therefore in this equation we have to put z equal to 0. So if we put z as 0, we will be getting x square plus y square to be equal to a square. So let us write that. So x square plus y square is equal to a square. Now from this we will be getting y square to be equal to a square minus x square, which will imply the value of y is equal to plus or minus square root of a square minus x square. Using the same fact that we are considering only the positive octant, the value of, the limit for y varies from y equal to 0. Since we are considering only the positive octant, we will consider only the positive values and we will ignore the negative values. Therefore y will vary from 0 to to y equal to square root of a square minus x square. So therefore these are the limits for y. So after finding the limits for y, finally we have to find the limits for x. To find the limits for x, we should consider the x-axis. And we know that in x-axis, y is equal to 0 and z is equal to 0. So therefore, we have to put y is equal to 0 and z is equal to 0 in equation 1. So if you see, in equation 1, if you put z as 0 and y as 0, y as 0 and z as 0, then we will be getting x square to be equal to a square. So let us write that. So x square will be equal to a square, from which we will get the value of x to be equal to plus or minus square root of a square, and therefore x will be equal to plus or minus a. But again, using the same concept that we are considering only the positive octant, the limit for x varies from x is equal to 0 to x is equal to plus a, that is a. So therefore the limits for x is 0 to a. So we have found the limits for x, y and z, and after finding the limits we shall evaluate the given integral. So this integral has to be written with limits now. And since x is independent of any variables and it varies only between constants, that will become the outer limit, that is the limit of the last outer integral. So this is with respect to x. And the second integral will be with respect to y, since it is dependent on one variable only, that is here we have the limit of y is dependent on one variable x, and therefore it will become the limit for the middle integral. So y will vary from 0 to square root of a square minus x square, and finally the inner limit will be for z, which is equal to 0 to, so what are the limits for z? It varies from 0 to square root of a square minus x square minus y square. So let us write that a square minus x square minus y square, and the question and the function given is x, y, z, and since the inner integral is with respect to the limits z, we have to first integrate with respect to z, and the second middle integral is with respect to y, so then we have to integrate with respect to y next. After that, at last we have to integrate with respect to x, as the limit of the outer integral is with respect to x. So this is the integral that we have to evaluate. Now let us start to integrate this. So as per the order of integration, first we have to integrate with respect to z, and so the so this will be equal to 0 to a. The second integral also remains as it is, 0 to square root of a square minus x square, and then we have to integrate here z alone, that is xy will be treated as constants. In fact, you can write it outside here, and the integration for z is z square by 2. This is by the formula of integration, so it is z square by 2, and this is between the limits 0 to square root of a square minus x square minus y square, and we will be left out with dy dx. Now we shall apply the limits. Since we have integrated with respect to z, at the place of z we have to apply the upper and lower limit. So this will be equal to integral 0 to a, integral 0 to square root of a square minus x square, xy will come as it is, bracket, when we apply the upper limit, it will be square root of a square minus x square minus y square, the whole square, and the square and the square root will vanish, and so we will be having a square minus y square minus, x square minus y square. So remember, at the place of z we will be putting square root of a square minus x square minus y square, and since we have z square over here, the square root will vanish when we square it. So therefore we will be left out only with the inner term. So a square minus x square minus y square divided by 2. And when you apply the lower limit, it becomes 0. So I am not showing that here, because upper limit minus the lower limit. So when you apply the lower limit, it becomes 0. So dy and dx comes as it is. This 1 by 2 is a constant which can be taken out. So this will be equal to 1 by 2 integral 0 to a integral 0 to square root of a square minus x square. Now this xy we shall multiply to each of the terms inside this bracket. So first we will multiply with a square. So we will be getting a square xy minus, next we shall multiply it with x square. So we will be getting x multiplied with x square is x cube y minus, next we shall multiply with this term y square. So x Y multiplied with y square is y cube. And then dy dx. And this 2 already we have taken out over here. Okay, 1 by 2 we have taken out of the integral. Now next we have to integrate with respect to dy. So we shall now integrate this with respect to dy. So 1 by 2 will come as it is. Outer integral is 0 to a, and the inner integral now we have to integrate. So this, when integrated with respect to dy, a square x will be treated as constant. So they come as it is, a squared y. And what is the integration of y? It is y square divided by 2, minus x cube will be treated as constant, so it will come as it is, and the integration of y is y square divided by 2. And then we have xy cube, and x will be treated as constant, so minus x will come as it is, and the integration of y cube is y to the power 4 divided by 4. And this is between the limits 0 to square root of a square minus x square, and then we will be having dx. So this is after integration with respect to y. Now we shall proceed further. Now we have to proceed further by applying the limits. So this will be equal to 1 by 2 we will have as it is, integral 0 to a. Now this a square x will come as it is. And what about y square? At the place of y, we have to apply the upper limit. Upper limit is what? Square root of a square minus x square. So when we apply it and square it, since we have y square over here, the square root will vanish and we will be getting a square minus x square divided by 2, minus. Now here x cube will come as it is, and when we apply square root of a square minus x square at the place of y, again the square root will vanish because we have y square over here, and therefore we will be getting a square minus x square divided by 2, minus. Here again when we apply, here we have y to the power 4, so it will be square root of a square minus x square the whole power 4. So square root will vanish, and again the term a square minus x squared will be squared, and so we will be getting a squared minus x squared the whole square, because it is y to the power 4. So remember very carefully, here we had y square, so we just took out the square root and we wrote the term. But here since we have y to the power, we took out the square root and squared the term again, since we had y power 4, and this divided by 4 we have to write, and dx will remain as it is. So this we will be getting. Now we can take the LCM throughout. So if we take the LCM, what we will get? So this will be equal to 1 by 2 will come as it is, integral 0 to a. Now let us write a common denominator. So the LCM we can see that it is 2 comma 2 comma 4. So the LCM is 4 for this, and so 2 has to be multiplied with this denominator, and the same 2 has to be multiplied with the numerator in order to get the 4 which is here in the LCM. So it will be 2 a square x multiplied with a square minus x square. Again here also 2 we have to multiply. So 2x cube multiplied with a square minus x square. I can in fact multiply these terms within here and within the bracket here itself, but since I want to show you step by step, I am not doing it here. I am just multiplying the I have just taken the LCM, and I am just doing it, and this minus will come as it is, and since we have already 4 over here, we have to just rewrite this term, and while rewriting this x we will write as it is, and this a square minus x square we can see that it is whole square. So we can expand this by using the formula a minus b, the whole square formula. So it will be a to the power 4. Since a square the whole square, we will get a power 4, and then minus 2ab. So minus 2, instead of at the place of a we have a square, and at the place of b we have x square. So this, and then plus x square the whole square, which will be written as x power 4. So close the bracket, and this is with respect to dx we are yet to do. So that we will write. So that is further equal to 1 by 2. This 4 can be taken out. So 1 by 2 multiplied with 1 by 4. So I have written that 4 over here. Integral 0 to a. Now we will multiply this term within the bracket, and so we will be getting 2 a square into a square a power 4 x minus 2a square x multiplied with x square is x cube, and here minus 2a square x cube. Minus into minus becomes plus, and then 2x cube multiplied with x square will give us 2x to the power 5. This x has to be multiplied within the bracket, so minus a power 4x minus into minus plus 2a square x cube we will get, and then minus into plus minus x to the power 5 we will have, because x into x power 4. Close the bracket and dx. So further this can be written as 1 by 8 integral 0 to a. We have to check whether we are able to cancel any terms. So if we see, we have minus 2a square x cube over here and plus 2a square x cube. So these two terms can be cancelled. And if you also see, these two terms we have, which can be written after subtracting x power 5 from 2x power 5. So what is 2x power 5 minus x power 5? It is only x power 5. Also we can see that 2a power 4x we have, and also here we have minus a power 4x. So 2 minus 1, which will be plus a power 4x. We can write it as it is. And we also see that we are left out with this term. So minus 2a square x cube. Close the bracket, dx. Now we shall integrate this with respect to dx. So that will be equal to 1 by 8. So after integration with respect to x, x power 5 we will be getting x power 6 divided by 6 plus a power 4 will come as it is since it is a constant, and the integration of x is x square divided by 2 minus 2 a square will come as it is, and the integration of x power, that is integration of x cube, is x power 4 divided by 4 between the limits 0 to a. Now we shall apply the limits over here. So that's equal to 1 by 8. Upper limit we have to apply first. So a power 6 divided by 6 plus, when you apply a at the place of x, we will get a square. A power 4 multiplied with a square is a power 6 divided by 2 minus, here we will be having a power 4. A square multiplied with a power 4 is 2a to the power 6 divided by 4 minus the lower limit. So when you apply the lower limit, it again becomes 0. So we need not worry about it. We can proceed further. So that is equal to 1 by 8. We see that the LCM for these three terms within the bracket is 12. And so we will be having 2a power 6 plus, and multiplied with 6. So 6a power 6 minus, and here we will be having 4 3 times is 12, so 3 2 times is 6, so minus 6a power 6. So we see that plus 6a power 6 and minus 6a power 6 gets cancelled, and we will be having this term to be equal to 2a power 6 divided by 8 multiplied with 12. So this we can cancel. 2 1 times 2 6 times is 12. So that's equal to a power 6 divided by 8 6 times is 48. And therefore the solution is a power 6 divided by 48. So therefore we have evaluated the given integral, that is the triple integral xyz dx dy dz over the positive octant of the sphere, and hence we have evaluated it to be equal to a power 6 divided by 48. In fact, we can call it as the volume of the sphere in the first octant with respect to the function given in the integral. So I hope you would have understood this problem. In our next video, we will solve another significant problem under this topic. So kindly follow the upcoming video lecture on this topic. Thank you.